Today, I'm going to talk about what's coming up in React. Before we do that, my name is Ari. I live in San Francisco with a very adorable dog who has doggy stairs to my bed. She's a corgi. She's got tiny legs. Okay, so I have a small publishing company in San Francisco. I am a co-author on Full Stack React, which is like a book this thick on React, including topics like GraphQL and Redux. And one of the things that I'm most proud of is we keep it up to date. Also, there's a 50% discount while I am in Israel, so write that code down if you want to grab it. Like I said, we keep it up to date. Okay? All right, so with no further ado, let's talk about what is new in React. Presumably I don't need to say this, but React is pretty rad, right? Thank you. Yeah, it totally is. One of the reasons why I think it's rad is it's a UI, it's an interface for describing user interfaces. It's a code interface for describing user interfaces. One of the nice things that React does is it takes care of a lot of things for us automatically. I don't really need to convince a React crowd about why you use React. But the important part of this is that React 16, the next version of React, doesn't change this. Nothing I'm talking about today is going to impact the usage that we have all fallen in love with React. The other thing is there's a lot of theory talks out there about how things work. Today, I really want to focus on the practicality of React, of the next version of React. So for that, I'm going to be showing lots of code slides. Also, the application and the slides are all open source. In order to prepare for this talk, I wrote a React app using Create React App, the Create React App script, and I added a few components to it, React Router DOM and styled components. That is where the application lives on GitHub. Okay, so now let's talk about what's new. First things first, when you update your application to use the next version of React, you get an automatic optimization of a smaller bundle. So currently today, if you download React and React DOM, gzipped, at the smallest you can get it, is approximately 44 kilobytes. If you install ReactNext and React DOM next, it's already at 39 kilobytes, approximately 39 kilobytes gzipped. So you already get a little bit more optimization simply by moving versions. Another thing that's changed is all the deprecation warnings that you get in React 15 are now actually errors. All the deprecations are now errors. And part of that has to do with the fact that they stripped out a lot of the core packages. So if you want to use things like prop types or create class, you need to install an extra package. So for instance, this is a really simple React component. If you try to run this application, if you try to run this component in React 16, you'll get an error because React prop types no longer exists. So you need to change the way that you use React, or prop types in React by using it from, or by installing the prop types package, not from React. Okay, one of the coolest parts about React 16 are the component return types have now expanded. Have you ever been writing a React app and you're like, oh man, I just need two components sitting next to each other, right? Like a sidebar component and a container component. Wouldn't it be really easy if you could do that? Unfortunately, that produces an error because in JavaScript, when JSX turns this into JavaScript, it's invalid JavaScript, so it won't work. So instead, what we need to do today is enclose that in a single child element. So here we have this extra div. Unfortunately, that produces an extra DOM element. It makes our DOM tree much bigger and adds totally unnecessary complexity in styles. So like Flexbox, for instance, you kind of have to hack around that. Ideally, what we'd like to do is, go back to the first usage, which should be something like this. It would be really nice, right? Because then your flexbox style is just a single component. Well, in React 16, you can now return arrays. You don't have to return a single component, you can return multiple components. So notice here I'm returning an array of 2 components. And this is valid JavaScript, so this works. However, if you try to run this in our browser, we'll see that we get that each child in an array or iterator should have that unique key. I don't know how many times I get this error message. It's like every time I do an iteration, I have to be like, key, I forgot. So we can still get that same thing to work just by adding a unique key. Unfortunately, that's kind of gross, right? All right. Second time. Third time, I expect everyone to say that. So can we do better? Yes, I think so. I can't claim credit for this idea, for this concept, but there's ReactNext is a package that came up with this, and it's actually a single line package. What we can do is we can wrap our component in another element that doesn't actually put a DOM element, an extra unnecessary DOM element in the view. So ReduxAux is a package that does that. It literally is the entire package right there without the package JSON. And what that allows us to do is we still have to wrap, visually, we still have to wrap our component in a single outer component, like so. But in the DOM, we remove that unnecessary div element. And that makes Flexbox play nice. And our DOM tree is smaller. We can also return strings as components, which is pretty nice. Let's say that we want to support multiple languages in our application, and we have kind of a really naive way of implementing I18N support. For instance, here I have an object that exposes some keys to both English and Spanish. I also use Google Translate for this, so sorry if you actually know Spanish. So this component is actually a real component. Even though it returns just a string, we can use this component just like it's any other React component. So for instance, in our sidebar, in our demo application right here, can you see that? In our sidebar component, I have English enabled right now, and let's go enable Spanish. Oh, it's in home. Hooray, it worked. And that's just a single component, which is pretty nice. We can also do the same thing for numbers and Booleans as well. I think that's really cool. Another thing that React 16 brings into our React apps are the ability to add custom components without warnings. So if you've ever tried to add like a data tag to an element, and you get, I don't know what that thing means, perhaps you meant this other thing. React 16 allows us to add these custom attributes. And it will just keep them, it'll just pass them right through. This actually just has to be on DOM elements that the browser knows about, not on custom elements. Okay. Raise your hand if you've heard of Fibre before. Either we're not interactive or nobody's really heard of it. Cool. I'll go with the first approach. So raise your hand if you know what the reconciler is. Okay, so the reconciler, React Fibre is a complete rewrite of the React reconciler. Reconciliation refers to React's diffing algorithm, which is what allows React to be performant and fast and still predictable. When React is looking at changes, when it's looking at how the next version of the UI should look, what it does is it crawls over the DOM tree and it looks at the things that have changed. One of the reasons it does that is for speed optimization, so it doesn't have to replace elements that haven't changed. And there's a lot of tricks that the React team has implemented that allows it to be really fast. And that's what they call the reconciliation algorithm. One important thing to note is that although this does add features, the React team has worked really hard to make sure that it's backwards compatible. So the core React functionality is exactly the same. React Fibre improves the perception of performance. It doesn't actually speed up our browser. It's pretty hard to speed up code that you don't know is going to be written or how it's written. But what it does is it brings intelligence into the rendering. And what that does is it alleviates the main thread. So not only do we get speed improvements inside of React itself, but we also get speed improvements in our own functionality, in our own code. So rendering itself feels a lot faster. From a really super high level description, React Fibre brings us the ability to have asynchronous rendering and scheduling and prioritization of what gets rendered when and what gets run when. Basically, it just makes rendering smarter. The way that it does that is it divides the rendering cycle. So right now, there's just one big rendering cycle in React, and that includes the reconciliation as well as the rendering, the flushing to the DOM. What React Fibre does is it breaks that out into two phases. We have the reconciliation phase where it spends the time computing what is going to be changing, and then we have the rendering phase. The rendering phase is where the new tree gets flushed out to the DOM. The reason why this is important to know about is that the reconciliation phase is interruptible. So as React Fibre is computing the next changes, we can interrupt that, move to a higher priority task, and then move back and do some more reconciliation work. And we as developers don't necessarily, we're not going to interact with that ourselves unless we want to. We can add priority to the work that we can add priority to the work in our code. However, most of the time we won't have to do that. And then the rendering phase, that's where everything gets flushed out to the DOM, and it's impossible to make that interruptible. So what React Fibre, the way that this works is it brings in scheduling, the idea of priority in work. So there's a lot of work that we have to do inside of our web applications, things like asynchronous fetch calls to a backend web server, or animation, if we want to control animation with a React component. That's a pretty high priority task because you don't want your animation to feel sluggish. Rendering on-screen components, also a pretty high priority task. You don't want a space for a component to exist or have a component exist where it should exist and it's not there. And then rendering off-screen components, that's a low priority task. If we're not looking at something that's not on screen, then why spend the time, why spend the cycles rendering it? And background computations. So basically, at the root of it, Fibre chunks the main thread. So we run chunks of different work at the same time as we're running the reconciliation for our application. So today, in React 15 and down, basically the way that React runs an app is we mount that application. We'll run some main work, and what I mean by main work is the code that we write as consumers of React. Then we'll render a new UI, and then we'll repeat the process. Today, that rendering UI, the new UI is a blocking process. So that runs when it does the reconciliation phase and the rendering phase in the same cycle. That blocks every other piece of work from running. Ideally, what we would like is we'd like to mount our application, run some main work that our consumers, we as application developers, write. Check for any idle processes, and inside that idle process, when we're not actually doing any computation, then run other computations that React can do in the background. So this is where the reconciliation phase gets called. And then we'll just repeat that. So I really love this diagram. Lynn Kark she's a cartoonist. She's pretty fantastic at describing how things work. That's her talk. I highly recommend if you want to know deeply how React Fibre works. That's a really great talk. This kind of demonstrates the difference between the main rendering thread that we have today and React Fibre, which executes here the execution for React is handled in between the execution for our main code. So I told you I wanted this to be practical, so we created a small demo. So this is a demo application with 1,000 components. It's making a fetch call in the background and running computations for each one of those 1,000 components, and then coloring it and updating it. This is actually running. Oh, I totally should have done this on React 15 to show you the difference. Come find me after. I'll be here. I'll show you the difference. This is actually pretty performant. This is really fast. This is making a fetch call, which is low priority work. So as React is rendering, the fetch call is sent out. When that fetch call comes back, then we have higher priority work that gets pushed in, which is we're changing the DOM. And then React does that nice little reconciliation comparison in our DOM tree, and we get our new components. Also, React Fibre makes it really easy to add renderers. So today we have renderers like React Native, which is pretty rad. The current renderers, unless they're doing something super custom, should just work on React Fibre. That's kind of what a lot of the work right now that the React team is doing right now to make sure that a lot of these renderers have support. So when React 16 does come out, they all should just work. So another thing that React 16 is going to bring is error handling. So right now, when you write a React app and you get an exception thrown, what happens? Yeah, it blows up. It shows a white screen if you're not lucky. Or if you are lucky in production, would that be better than just showing a broken app? I think it would be better just to show a white screen. So currently right now, if there's an exception thrown that's not handled in a try-catch block, your application just blows up. React 16 introduces the concept of error boundaries. If you've ever, I feel like everyone has run into this, so I don't need to ask that question, which is, have you ever run into this problem? So error boundaries are, it's a really complex term for a really simple idea. So what an error boundary is it's a component that catches any, it's basically like a try-catch component that will catch any UI or React errors, something that happens in a lifecycle thread or something that happens in the rendering thread or the rendering phase. We can implement a custom component that can show custom UI, so our users don't see nothing or a broken application. Instead, they can see a helpful message that says something like, something bad happened. The way that it does that is by introducing another lifecycle hook called componented catch. This is the ooh-ah moment. Let's try that. Ooh-ah. It's like taking a sip of water after you've climbed Masada. Topical humor. Okay. So for our demo application, we can use something like an error boundary, or we can implement the componented catch in an error boundary component, and we can do whatever we want inside of here. One common thing that you would do is you throw something to like bug snag if there's an error and say, oh, we've been warned inside this component. One of the nice things is it's just a regular component, and we can place it inside of our DOM tree wherever we want. So an example of this is if rather than just blowing up, we still want to show like the header and the footer and some content on the page, we can still do that just by placing an error boundary inside of our DOM tree. So in our application here, let's say that we have a buggy component. And this is a development version, so I have a production version running too. So let's throw an exception. Something bad happened. But one thing that's really nice is our header and our footer. That's all still there. All right. The last thing that I want to talk about today is server-side rendering. If you've ever tried to do server-side rendering or a universal application, React 16 brings first-class support for React for streaming responses on React from Node. The reason why you'd want to do something, why you want to pass back streaming responses, is rendering your entire application, especially large applications, into a string is memory intensive, and it puts unnecessary work on your server, where your server really should just be there to serve assets and lazy loaded components. This can take your server down if you do this too often and too much, and you don't cache the components. Instead, we can render a stream from from Node. We can render a stream. So we can take our application, and rather than rendering it one time, putting that entire string into memory and then shoving that down to the browser, React DOM from React 16 allows us to render that into a stream and just pass that stream as the rendering is happening. It's much more performant. I think that's really cool. React 16 also brings a lot of performance optimization to server-side rendering. So we get lightning fast speed, in fact, an order of magnitude from React today. And also one other nice thing, if you've ever tried to do isomorphic or universal, depending if you're a cool kid or not, the React ID tag doesn't get rendered on the server. That way the client can hydrate those. All right, and you can use this today by using npm or yarn to install the next version and just append @next if you want to do that today. It's RC3 right now, 16 RC3, so it should be released anytime soon. I don't have any inside information on that. The only thing is that asynchronous rendering is disabled by default in React 16, and it will be enabled by default in React 17. So if you want to play with the async rendering, there's a really good resource to show you how to do that, and it's just a single line. It's a single line sed call. In order to make these numbers work, this is done with async rendering. So, yeah, that's my talk. Are there any questions? And that's the code again if you want to grab the book. It's 900 pages long. My mom is proud. Anyway, any questions? So the question is, how does React 16 affect the initial page load? If you're doing server-side rendering, it's faster because you're streaming that response. And we're also sending a smaller bundle to the browser, so it should be faster from a network perspective too.